All right, today we're going to be solving problem 16P43, which we have a tube here that we're trying to find the total charge of the tube. We have the total charge at Q. So the first thing we need to do is we need to find the charge per unit length. So we're going to say delta Q is going to be equal to Q over L. L being the total length of the tube. Obviously, the charge is dispersed evenly. Okay. So the next thing we need to do is we need to divide the tube into equal segments. The easiest way to model this is we're going to use the formula for the electric field of a ring. So we're going to divide this into very, very small rings. So we can say that the charge per ring, so dq, is going to be equal to the charge per ring, charge per length, unit length, Q over L, dx, over the total length of the tube. So we know that the formula for E of a ring is equal to 1 over 4 pi sigma naught times QZ over R squared plus Z squared to the 3/2. So first thing we're going to do is we're going to replace the charge Q with the charge per unit length of the ring. So let's say E ring is equal to 1 over 4 pi sigma naught times Q over L times Z dx over R squared plus Z squared, the 3/2. Okay, so the first thing that we notice here is that there's no x value for us to take dx with. So we need to put Z in better units along the length of the tube. So by looking at the tube, we notice that the distance from a point, the point W, to the center is Z equals W minus X. So when we plug this into the formula for E ring, it gives us D, E ring, is equal to 1 over 4 pi sigma naught times Q over L times, we're going to have W minus X dx over R squared plus W minus X squared all to the 3/2. So in order to get the total electric field over the length of the tube, we're going to have to integrate this over the length from 0 to L. So we know that 0 is less than or equal to x, which is less than or equal to L over the full length of the tube. So integrating, we get the electric field of the tube is going to be equal to the integral from 0 to L of 1 over 4 pi sigma naught times Q over L times W minus X dx over R squared plus W minus X squared all over 3/2. So when we take this integral, which is a somewhat complicated integral, we can use an integral calculator to find it. And we find that E tube is equal to 1 over 4 pi sigma naught times Q over L times quantity 1 over R squared plus W minus X squared to the 3/2 evaluated, to the 1/2, not 3/2, evaluated from 0 to L. So we're going to plug in 0 to L for our x value. Once we do that, we get a final answer of E tube equal to 1 over 4 pi sigma naught times Q over L times 1 over R squared plus W minus X squared to the 1/2. That's all one quantity. Minus 1 over R squared plus W squared to the 1/2. That's our final answer.